Hi everyone, and welcome back. I hope those of you who have off work today are enjoying the short week. Otherwise, let's do some statistics. The topic for today's lecture is going to be the normal distribution and area under the curve. So let's talk about what that means. We talked last time about probability distributions. If you recall, probability distributions tell you all the different values that a variable can take on. In other words, some set of outcomes of a probabilistic event and the probability of each one occurring. We also showed that you could graph them, so you could show all the values on the x-axis and show the probabilities on the y-axis. This here is a probability distribution that will become a big part of our lives over the next couple of weeks. And what this distribution shows is the probability of getting any value that you might have along the x-axis. So it's a very high probability in the middle and a lower probability as you get farther away from that middle. Before I talk about it in more specific details though, I just want to point out that this is a type of probability distribution and distribution of data that appears in a lot of different things naturally. So for example, test scores and SAT scores often take the shape of a normal distribution, which is what this is called. Many characteristics of living creatures, so things like birth weight, often have a normal distribution as well. So you have the highest probability of having a birth weight in between about 3.5 kilograms, I don't know what that is in pounds, and then it's less likely that you're going to have a very tiny baby and less likely that you're going to have a very large baby. Height, another natural sort of variable that takes on the same distribution. And I pulled all these pictures off the internet, so here we have the height of English male criminals measured around 1900. And what you can see is that the most common height was around 5.5 feet, so the greatest probability of picking a criminal with a particular height would be around for about 5.5 feet, and then it's much less likely that you're going to have a really short criminal. It's much less likely that you're going to have a really tall criminal. So all these probability distributions show the same thing. There's a central value that's the most likely, and then the farther away you get from that central value, the less likely it becomes. Pizza delivery times. So the most likely amount of time it's going to take for your pizza to come is 30 minutes. And it's less likely that it's going to come really, really soon, and less likely that it's going to take a really, really long time. And then finally, the distribution of calories in Chipotle meals. If you get a meal at Chipotle, it's most likely that the meal will have about 1,000 calories in it. It's less likely that it'll have much less than that, and it's less likely that it'll have much more than that. And for some reason, this slide always makes me want a burrito. So before I get into this slide, I'm going to hop over to the document camera and talk a little bit about these normal distributions, and then also show you the notation that I'm going to use when I talk about them more.